This is one of the graphics of which I am most proud all semester. I take a little round of applause for how fabulous that graph is. Thank you, thank you, thank you very much. Because the first two times I tried to explain these different types of sampling, folks weren't getting the hierarchy or the organizational way. Can't finish that sentence. Folks weren't getting it. With the picture, I hope to help you understand that there are two main types of sampling, only two. There's non-random and there's random. That's it. Every kind of sampling could be put in one of those two categories. Guess what the thumbs down right here means? This is the bad one. This is the good one. Non-random sampling leads to a sample that is quite likely not to be representative of the population. Two types of non-random are convenience and voluntary response. We've talked about why voluntary response isn't good. If you post a survey on the internet and say, click here to take the survey, only the people who have strong feelings about that subject are going to click on the link and take the survey, and they may not feel the same way the general population does. That's why voluntary response is not a good kind of sampling. Convenience is just asking the 10 closest to you, but getting data that's easy to get. If I wanted to find out what percent of Cumberland County population would say that attaining a college degree is very important, it would be very easy for me just to ask you all, poll y'all. And when I poll y'all, because y'all are close to me, and I get what percent of y'all think that a college education is important, could I make a generalization then about how folks in Cumberland County feel? Y'all are sitting here. You must value it to some degree. Some of you probably value it more than others, but your answer to that question is likely not to be representative of the folks who aren't in college. And then again, it may be. Maybe they want to be in college. But just asking the folks that are easiest to grab is not the best way to do a sample. The good or better kind of sampling is random sampling. So here go my hands again. There's random and non-random. Non-random, two types. What are the two types of non-random? Convenience and self-selected or voluntary response. There are 4 kinds of random. Simple random is the best. Not always possible. Simple random, systematic, stratified, cluster. This has a wiry definition. We're going to have to think hard about this definition and this definition. Random and simple random. We talked about that. Random sampling is a selection so that each individual member has an equal chance of being selected. Again, if I was trying to make some generalization about the importance of higher education to citizens of Cumberland County, I couldn't just take my sample in this room, because then not everybody's view was equally likely to be solicited. There were folks who aren't in this room who didn't even get to say what they thought about the value of higher education. So it's only a random sample if everybody in the population, whatever the population is, had an equal chance of being chosen. Simple random, the definition of simple random is a group of n subjects, n's just any number, selected in such a way that every possible sample of size n has the same chance of being chosen. Let's say I want 10 people in my sample, and I'm still trying to figure out what Cumberland Countyans think about the value of higher education. I want 10 people in my sample I have to choose my sample in such a way that any group of 10 has an equally likely chance of being picked. Socioeconomic classes, I could have folks at the higher end, folks in the middle, folks in the lower end, whether or not your parent has a college degree, that would probably affect your answer. But a simple random sample, any possible group of 10 is equally likely to be chosen. So there's no discrimination there. Difference between the definitions of random and simple random are random, each individual has the same chance of being chosen. Simple random, each group has the same chance of being chosen. I don't expect that makes sense yet. Let me keep going and it will in a minute. For example, pharmacists typically fill prescriptions by scooping a sample of pills from a larger batch that is in stock. A pharmacist thoroughly mixes a large batch of pills and then selects 30 of them. Is that a random sample? Well, let me tell you how the easiest way to answer that question in the homework. Is it random? There are only two kinds of non-random. You know what they are. What are they? Convenience and voluntary response. If it's not convenience or voluntary response, then it's random. Every pill had the same chance of landing up in the scoop. So it's not convenience, it's not self-selected, it's definitely at least random. But let's think about whether it's simple random. These pills are in a tumbler being mixed. Does every group of 30 have the same chance of being scooped? There's nothing that makes one set of 30 more likely than another set of 30. They're just all mixed up and I'm just scooping out 30. That's random as random can be, also known as simple random. My definition of simple random is random, period. Random and nothing else. If it's random and no other method has been applied, then it's also simple random. But there are randoms that aren't simple randoms. Right here, here, there are 4 kinds of random. Simple random's only one of them. So we're going to have to talk about these other 3 kinds. We need to finish this next problem though. So we said this was random. Was it simple random? Yes. Every group of 30 pills, any group of 30 pills, was equally likely to end up in the scoop. Number 24, in order to test for a gender gap in the way that citizens viewed the current president, the Tompkins Company polls exactly 500 men and 500 women randomly selected from adults in the United States. Does this represent a random sample? Did everybody have the same chance of being picked? Yeah, it's random. Were there any rules applied after that? Am I just going to scoop out 1,000 people, or are there some groups of 1,000 that's not just going to be possible under these stipulations? This is a sample size of 1,000, and there are groups of 1,000 that cannot occur under these conditions. I can't have a group of 600 men and 400 women. That can't occur if I'm following orders. I can't have a group that's all men or a group that's all women. So not all groups of 1,000 are equally likely there. So what does that say about simple random? It's not. Every individual had the same chance of being selected in the beginning, but once somebody put in this rule, it's not simple random. It's random, but then something else was applied. So it's random, but not simple random. A classroom consists of 36 students seated in 6 different rows with 6 students in each row. The instructor rolls a die to determine the row, and then rolls the die again to determine a particular student in the row. When I walked in the room with 2 die, did everybody's number have the same chance of coming up? Yes, it's random. I'm letting a die decide. It's random. Everybody, unless my die is only numbered 1 through 6, but there's a row 7, that wouldn't be random because then those folks didn't have a chance to begin with. But if I only have 6 rows and I have 6 sides on my die, then it's random. Is it random and nothing else? It's random and then something else. It's random in that every individual had the same chance of being chosen, but I'm going to obtain a sample of 6 students. Once I roll that die the first time and say it lands on a 3, and I've picked this row, all of a sudden, no groups can be made with any of y'all in it. So all groups of size 6 are not equally likely because once I've picked a row, I've excluded 30 of the 36 people in the room. So it's random in that every individual had the same chance of being selected, but it's not simple random because it's random and then there was a method applied. Think of it that way. Random and no method is simple random. Random and then a method applied is not simple random. It's one of the others. By the way, this is what I was saying is the hardest thing in 1.4. Understanding the difference between how can something be random but not simple random? Could something be simple random but not random? Simple random is one of the 4 in the random category. It's never going to be in the non-random category. So that is random but not simple random.